about 1915, mining was already well developed in the Sudbury area. Garson Mine had been brought into production in 1908 and quickly became the Mon Company's biggest producer, with 10 underground levels by 1915. The Garson town site was built by the company to house the miners. Both town site and mine are still in business. The Worthington mine, southwest of Sudbury, was discovered when a prospector noticed copper in the ballast of CPR's line to Sault Ste. Marie. And the Victoria mine, known then as Old Reliable, was the deepest mine in Canada, reaching to 3,000 feet. It was the first property purchased by Ludwig Mond of the Mond Nickel Company. It cost him $200,000 in the summer of 1900. Most of the operating mines then, and also today, are on the south rim of the Sudbury Basin. But on the north, the Levack mine had already produced 50,000 tons of ore. Diamond drilling was already used to determine the location and extent of ore bodies, and systematic geological exploration had begun about 1900, when the geological structure of the area around Sudbury had first become recognized. By 1914, nearly 50 million pounds of nickel and 30 million pounds of copper were being produced annually. The First World War had brought boom times to Sudbury. But almost everything still depended on the muscle power of the miners once they were underground. Technology had still not greatly altered the way things were done underground, the way that it had altered the way the ore was processed when it reached the surface. Muscle power was still necessary to push the ore skips. And the lights that the miners wore were still powered by carbide and water. Electricity was still not available underground in battery form. Here the carbide powder is loaded into the lamp, and the addition of water produces acetylene and a naked flame. This caused considerable problems in coal mines because methane gas exploded on contact with the flame. But it was no problem in ores, metallic ore mines, as at Sudbury. Drilling was probably the most advanced of the underground procedures at the time, far advanced from the hammer and the drill steel days of just a decade or two before. The drills needed to be firmly mounted on posts between the floor and the roof of the drift. Compressed air had recently taken over from steam as the power for the drills. This compressed air came from compressors at the surface. The drills were water-cooled, and about a dozen holes were drilled between 4 and 10 feet deep at the ends of the drifts. And then the drill had to be moved to another site. This was still an arduous procedure, and sometimes perhaps not a very safe one. Following the drillers came the dynamiters. The dynamite was prepared on the surface, detonators and fuses being attached to the dynamite, and then brought into the drifts underground. About 1 pound of dynamite was inserted for each foot of hole. And at the end of a drift like this, something like 30 pounds of dynamite was placed in the holes. The 8-foot-long fuses burnt for about 4 minutes. And they were all, of course, fired by the flame of the carbide lamps. And then once the blast was over, muscle power came into its own again. the ore being laboriously shoveled into the skips. The drilling of short holes was done with handheld drills, and here large blocks on the floor of a drift are being prepared for dynamiting. Electricity was in fact sometimes used to fire the dynamite in such circumstances, but the flame of the acetylene lamp was usually more convenient and more favored by the miners. The pattern of drifts and inclined draw holes through which the ore was removed was not greatly different from today, although the amount of muscle power required is not what it was, and the methods of today are considerably more safer than this seems to be. Before being taken to the surface, the ore was held in storage pockets, and here the roof is being scaled. The safety of the roof being assured in much the same kind of fashion as today by inspecting for loose fragments. The fragments then, of course, being broken up and carried out. The cage system used to bring both the ore and the men up the shaft to the surface was based on a system of compensating balances. Signals on a gong indicating that a cage was ready to come to the surface. The Mond Nickel mine, which operated, or the Mond Nickel company which operated this mine, was amalgamated with International Nickel in 1929, and this film is one of the most complete records of mining technology at that time, about 60 years ago.